the parallelogram linkage, how to analyze the parallelogram linkage on Kirchhoff law. So in case length of two links is same, in case the length of two links are same, S plus L will be equal to P plus Q. So this is the condition, where S is the shortest link and L is the longest link and P is the other link and Q is the one more link. So in that case, P is equal to S and L is equal to Q. So these are the two conditions. So we are assuming the length of the links as S, that is the shortest link, as 36 and the longest link as 60. The remaining links P is equal to 30 and Q is equal to 60. That means P should be equal to S. So P is equal to S, but that is equal to 30 and Q is equal to L. Q is equal to L. Q is equal to 60 and L is equal to 60. So this is the condition. So the next thing is, now equal links are opposite to each other. When the equal links becomes opposite to each other, then you will going to get a parallelogram linkage. So now we have to analyze this. How to analyze this? For this, first we will going to create the model. So to do that, I will go for the fusion screen. Now first we will go to the pod design and make it as hybrid and say convert. Then the first link what I will going to consider is 30. So to do that, I will go for sketch, click on the front plane and I will go to create, go to slot, take center to center slot first of any length. Then go to dimension, select this and give the dimension as 30. Okay. Then take the radius as 10. This is the assumption what we are taking the values from the data. I'll go for constraint, select midpoint. Midpoint of this line should be at the origin. I will select this. Now it is totally constrained. Now we will go for circle, select some arbitrary point and draw two circles. Then go to equal constraint between this circle and this circle. Then go to dimension, select this and give the diameter as 10. And then go to constraint, go to concentric, click on this and this circle should be concentric to this and this circle should be concentric to this semicircle. Now you disable the constraint to check, to show these are the dimensions of the model which you want to create. Once you do that, we'll take near to this. Once you do this, now this is the first link what we are trying to do. So I'll go for finish sketch and go to 3-dimension and then go to extrude, click on this and give the distance as 2 mm. Once you do that, now we will go for the offset. So you go to parallel offset plane, click on this plane, give the dimension as 0.2. Since you are going along the direction of the arrowhead, you take 0.2 and click on OK now. Then we will go for sketch, click on this particular offset created plane and then go to create, go to text, click on OK and create this text here. So what I want is go to Times New Roman, go to Times New Roman and take the font size as 5 and I will create the shortest link. I will mark this point as small s. Okay, click on. Then I will go for create, go to modify, click on more, enable, click on this text and by using the square block, you move it and place it approximately center of the profile and go to click on OK. Then go to finish sketch. Now we'll go for create, click on emboss. Sketch profile is this text and face is this one. And then take the engraving or embossing as 0.2. Okay. And then give OK now. So now you have the first link. So I'll go for appearance, then come down to paint, then come down to glossy. Now I will take this as the yes, that is green color, and I will say OK. So the first one we have created. So S is equal to P, correct? Yes. Now I will go to select this. I'll go for save. Now I want to save it as link S. Okay. Now I will create one more file of the same copy. I'll go to click on file, click on save as. Then go to link P and say save. I'm going to take this as link P, which is the same. So here I want to engrave this as P now. So to do that, I will just go to sketch, go to edit sketch, click on this sketch. Okay, double click on this. Sorry. Then you just click on this. Okay. Now I will create edit. Just double click on this. I'll go for right click. Okay. Now I will right click on this sketch tool and go to edit sketch, and then double click on this and make it as P, link P. Okay, click on OK. Now you want to save this file. Go to finish sketch. Now you go to save. Link P has been fixed. Now we have both link P and link S. That is because P is equal to S. Similarly, Q is equal to N. I want to do that. I will just go to exit. Now we go for convert, untitled, go to hybrid and say convert. Similarly, go to create sketch, click on this sketch again. So what is the length of the link? The length of the link is 60. I'll go for create, go to slot, take center to center slot first. Take any dimension. Go to constraint, take midpoint of this to this origin. Go to dimension, take this dimension as 60. Then go to radius, give the dimension as 10. And then go to circle, draw two circles of any length, any diameter. Then go to constraint, click on equal, select between these two. Now, then go to dimension, click on this, take the diameter as 10. Okay. Then go to constraint, select concentric, select on this circle with reference to this, and similarly select on this with reference to this. Now I will disable the constraint. So I will move this so that it can be modeled as per this dimension given. Okay. So once you do that, now we'll go for finish sketch, and I will go for extrude. Click on this profile and take the dimension as 2 mm. Now again go to the construct offset plane, click on this. Since you are along the direction of the arrowhead, give 0.2 and then go to sketch, click on this sketch that is on the offsetted plane, and then go to create, go to text and click on OK, and you create this P is equal to, now we want the length is the longest length. I will take capital L and say OK. Once you do that, now I want to move this, go to modify, move, select this, OK, and drag this and place approximately at the center, and go to click on OK, and then go to finish sketch. Now you go to 3 dimension and go to create, click on emboss, OK, select this profile, OK, on this profile, select this, sorry. Now you go to create, click on emboss, select this profile, OK, go to face, click on this face, and give the point to mm depth. You click on OK. Now we will go for appearance, then come down to yellow and click on this yellow and say close. So we have L. Now I want to save this. I will go for save link L. Okay. Then I want to save it again as link Q. We'll go for then go to file, click on save as, then link Q. Click on save. Okay. Now I want to edit this text now here. You just right click on this, go to edit sketch, and now you just double click on this sketch, make this as Q, link Q, and say OK, and then go to finish sketch. Now you want to save this file. So now we have all the conditions completed, or all the models have been completed. Now what we want to do is we want to go for parallelogram linkage. How these things which are going to vary. That is the one which we want to analyze. So equal links are opposite to each other. So that is the condition. So when the equal links are opposite to each other, how these conditions will going to take place, that we will going to analyze now. I will go for link, smallest links first. I will go for link P, equal links opposite. Sorry, cancel. Just go to this, make it hybrid and say convert. Then I will take equal links P, that will be automatically grounded. You can see here it is automatically grounded. Link P opposite. So you will have one more small link which will be opposite to that. S will be also opposite. Then obviously another link L will be adjacent to this. Okay. Now I will take this out and keep it here. Now I want to joint type J, which is the shortest. Short key for joint type J. Now you take the cursor. Once you take the cursor here on the surface, so it will go to snap all the points which are required. Then the one which is required for you, you need to select. I want to select the center of that hole. So by holding the control key, you drag this and take the cursor here and then click. Then you rotate this and keep it here. Right click and say OK. And similarly, you repeat the same procedure here. So this becomes, first time when you are doing it, it will be on rigid. Now since we are already doing and so many this thing, so it will automatically goes to the revolute. and say OK. Okay, then you go to 3D. Now I will just rotate it, and you can see it can be rotated about that particular point. So similarly, I want L and Q. I will take this point. I will take this link Q also. So now I will move it, move out. Then I will say OK. Then I will go for a joint. Again, you take the cursor on the surface. By holding the control key, you bring it to this point. Then you rotate this and you click on this OK and take the cursor on this point. So it will be rotated about that particular point. Now we have the uh, link which is fixed to the smallest link. Now we have this point. Now I'm rotating this. So we have one more point here. Okay. So these two have been rotated. Then we have both the points or both the links are in the same direction. Yes. Then I'm going to have link S now. Take the link S and keep it here. Similarly, you drag this and keep it out. Say OK. Click on joint. Take the cursor onto this and click here. And similarly on this side, click on OK and take the joint onto this and you rotate this point. Then click on OK. Then go to 3-dimension. Now we have this point which has been rotating. So similarly, I will go for a joint. Take the cursor on this surface by holding the control key. Take to this top surface of the hole. Click. Then you go to rotate. Then click on OK. And take the cursor on this surface and bring it to the center. Okay. So now we have all the links have been assembled. Click on OK now. Now go to 3-dimension. So now I need to analyze this. So when you have the shortest links, so what the condition says? Equal links opposite to each other. So you're going to get a parallelogram linkage. So now I will rotate this, go to relationship, go to joints. I will click on right click on this, click on animate joint relationships now. So when you do that, you can see here. So this will you will be having double crank mechanism when you have the parallelogram linkage. I don't want that relationship should be visible, and also so naturally you can see here if you fit. Now you can see when the shortest link is there, you can see that you have the opposite, that is adjacent to that shortest link, L and Q both are rotating by an angle of 360 degrees, and hence in the parallelogram linkage, when the shortest link is fixed, adjacent to that shortest link, which is link L and link Q are rotating by an angle of 360. That is why it is called the double crank mechanism. Now I will just escape this. Now we will try to analyze this for this particular S also. So to do that, I will just go to link P, right click and remove unground from parent. Now I will go for the link S and make it as ground to parent and say OK. Now let us see what will going to be the consideration. I will go for revolution, go to animate joint relationship. Now if you see here, you have the rotation which is happening. Again, you have the double crank mechanism. At one particular point of time, you can see that sometimes you will have the collinearity. So at that particular point, you will not be able to get the crank rotation. Instead, you will be, look here, you are getting this change of point. That is basically because when the link becomes collinear, both the linkages suffer from change point condition. That is, the output behavior becomes indeterminate. So that is why it is happening here at this particular point. If you see here, uh, it will be at some particular point it becomes collinear. So that is the reason why it is becoming rocker. So that is why it becomes indeterminate. It will going to have it in a the motion becomes unpredictable. Since the motion becomes unpredictable, it becomes rocker. So that is what they means. It becomes indeterminate. The linkage may assume either double crank configuration or crank rocker configuration at these positions. So that is why that is the condition what it will going to enhance. At this particular point, you will have crank rocker. Now this is double crank. What is happening? At some particular point when the motion becomes collinear, it becomes rocker. So that is the one which gives here in this particular parallelogram linkage. Now, this is when the shortest links are fixed. Now we will go for the longest links fixed. So to do that, I will just go to link, unground this link S, and I will go for link L, that is the longest link, and I will click on ground to parent. Now we will try to do this. If you fix the longest link, then see what happens. Go to revolution, go to animate joint relationship. Now you can see here also in one particular point where it becomes collinear, you will have the change point condition. So the motion becomes indeterminate and it will going to assume either crank or either it assumes the crank here, then it will going to be the rocker at this particular point. So this is what the change point condition when the parallelogram linkage wherein we have the larger link or the largest link is becomes fixed. Similarly, if you want the link Q opposite to that, so here I will unground from parent this link L and I will make link Q as ground to parent. Once you do that, now we will again go to ground relationship, animate joint relationship now. So here also you can say that one this crank and also it becomes rocker, both will going to happen. That is again because of change point condition. That is what it change point condition. It becomes indeterminate. The behavior becomes indeterminate. At that particular point, it becomes rocker. And when it, so here you can see this point P or the link P is becoming a crank and this opposite that link P is S. It is oscillating. That becomes the rocker. So this is how we will be able to analyze the parallelogram linkage for the condition when equal links opposite to each other is present. So when equal links opposite to each other is there, we are going to get the parallelogram linkage. And in this condition, we can get either double crank or crank rocker mechanism. That is basically because the crank rocker mechanism will appear only when the joint point condition appears, and in one condition wherein the smallest link is fixed, you will going to get the double crank mechanism. This is how you can be able to analyze the uh, you can analyze the parallelogram linkage in Grashof condition. Thank you.